basically what scalar products are used for is calculating the angle between two vectors. The formula that you're going to be introduced to in just a couple minutes here is basically the formula that will allow you to find the measure of an angle between two vectors, and you need to be able to calculate the scalar product, which is sometimes called the dot product, in order to be able to do that. So the first couple of examples, it's a very simple calculation. That's what the first couple of examples are, is how you actually calculate a dot product, and then it leads into what we actually do with it. So the scalar product, also called the dot product or inner product of two vectors, is defined by, so if you have two vectors u and v, you would take the x value of the u times the x value of the v plus the y value of u times the y value of v. That's in 2 dimensions. If you have 3 dimensions, again, you take the first 2 multiplied plus the second 2 multiplied plus the third 2 multiplied. The result is a scalar, meaning it's just a magnitude or a number. There's no direction attached to it, which explains why it's called the scalar product. So once you see how they're actually calculated, again, it's a pretty straightforward calculation. So in this first one, if we are asked to calculate the scalar product of the vectors v equals 2I minus 3j and w equals I plus 2j, if we want to calculate the dot product of v and w, this is how we notate it, or this is the notation used. This is the dot as in multiplication. What we need to be careful of when we get to other parts of the formula is that we don't use a dot for multiplication. You can use brackets or an X, because this dot here means we're not just going v times w. So to calculate the dot product or the scalar product of these two vectors, you take the 2 first numbers, so it's going to be 2 times 1 plus then the second 2, negative 3 times 2. And again, notice how I'm using brackets there rather than the little dot for multiplication, because you want to be careful you don't mix it up. So 2 times 1 is 2, negative 3 times 2 is negative 6. So the dot product or the scalar product here is going to be negative 4. So the next example, we have 3 values that we need to multiply together. This one, they don't indicate what the vectors are, so I'm not going to worry about writing down what they are. We'll just do the actual calculation. So here we take the 2 times 4 plus negative 5 times 1 plus 3 times negative 7. And then you're going to get 8 plus negative 5 plus negative 21, which equals negative 18. Last example, consider the vectors c and d. Calculate the scalar product. And again, this should be c dot d, or the dot product. Again, it's on your papers. I'm not sure what happened when it converted here. So here, you would take c d is equal to 3 times 5 plus 4 times negative 12. So we get 15 plus negative 48, which is negative 33, I think. Yeah.